Have you ever stopped and wondered who is actually building the AI-powered world that's popping up all around us? Well, today, we're diving deep. We're breaking down the career blueprint for one of the most critical, most in-demand roles in all of tech, the machine learning engineer.
First, just look at this number, 344%. Between 2015 and 2020, job postings for machine learning engineers grew by that much. That's not just growth. That's an absolute explosion. This is the kind of demand that defines a whole generation of technology.
So, that massive growth leads to the big question, right? Who are these people? Who are the specialists that are turning artificial intelligence from some sci-fi concept into the real-world tools we're all using every single day?
To really get this role, you first have to understand the moment we're in. We are living through what you can only call an AI gold rush. And machine learning engineers, well, they're the ones building the railroads, the boomtowns, all the essential infrastructure.
And the sheer scale of this opportunity is just mind-boggling. The AI and machine learning market is on a trajectory to blast past $500 billion by 2030. Think about that. That creates an almost insatiable demand for people who can actually build, scale, and maintain these incredibly complex systems.
And you know what happens when you have sky-high demand and not enough skilled people? You get some incredible financial rewards. This six-figure average salary isn't just a big number, it's a direct result of a major skills gap. See, the role requires this rare, hybrid skill set. You need the discipline of a top-tier software engineer, but also the deep statistical brain of a data scientist. And that combination, it's really, really hard to find. So companies are basically in a bidding war for the best talent out there.
Okay, so beyond the money and the market hype, what does a machine learning engineer actually do? In a nutshell, they are the architects of automation. So here's the official technical definition. They are software engineers first and foremost, but with a very special focus. Their job isn't to just write code that follows a set of instructions. No, their job is to build systems that can learn from data and then adapt all on their own. This is a brilliant way to put it. A data scientist might be the one who designs the beautiful blueprint for a new skyscraper. That's the model. But the machine learning engineer, they're the master architect on the ground who actually builds the thing, who makes sure it's stable, who connects it to the power grid, and who ensures it can handle thousands of people coming in and out every day. They're the ones who make the blueprint real.
So what's a day in the life actually look like? Well, it's this continuous, never-ending cycle. First, they've got to gather and clean up just massive amounts of data. Then they use that pristine data to develop and train the model. But here's the really crucial step, deployment. They have to get that model out of the lab and into a live working environment. And it doesn't stop there. Oh no. They have to constantly monitor how it's doing, and as new data comes in, they retrain it, starting that whole cycle right back at the beginning.
All right, so what does it take to become one of these architects? Let's pop open the engineer's toolkit and see what skills are absolutely essential.
Now, while people do come into this field from all sorts of backgrounds, there is a very clear pattern. Over 60% of machine learning engineers come from computer science or engineering, and that's not a coincidence. At its core, this job is about building robust software, so having that strong engineering foundation is absolutely key. When we talk about hard skills, some things are just non-negotiable. You have to be fluent in a language like Python. That's the baseline. And then deep expertise in frameworks like TensorFlow and PyTorch. That's what lets you build and scale these mind-bendingly complex models efficiently. It's the language they speak every single day.
But here's the thing. Anyone can learn a framework. Truly understanding why it works is a whole other level. The real power comes from a deep, intuitive grasp of what's happening under the hood. The computer science fundamentals, the heavy-duty math that powers the algorithms, the ability to wrangle data with SQL. This stuff is the absolute bedrock of the entire profession.
So what separates a good MLE from a truly great one? It almost always comes down to these skills. The best ones are creative problem solvers who see a failed model not as a disaster, but as a fascinating puzzle. They have an iterative mindset, almost a sixth sense for data, and this is huge, the ability to explain really complex ideas clearly to everyone else on the team. Okay, you've got the skills, you've built the toolkit. Now it's time to face the final boss, the notoriously difficult interview process, which is designed to test every single part of that toolkit.
I absolutely love this analogy because it's perfect.
You can't just be a fast coder. You have to understand the physics of the engine. That's the math. You've got to communicate flawlessly with your pit crew. Those are the behavioral skills. And you have to know what the other teams are doing. That's keeping up with the latest research. It's a total test of your abilities.
So preparation really boils down into these 4 key areas. You've got to have the core concepts down cold. You have to prove you can apply them in actual code. You need to be able to talk through your thought process, and you have to show you've done your homework on that specific company's challenges. If you neglect any one of these, you're going to stall out on the track.
You are absolutely going to get hit with core technical questions like this. This tests your fundamental understanding. Overfitting, that's like a student who just memorizes the answers for one specific test, but can't apply that knowledge anywhere else. Underfitting is like the student who barely studied and couldn't find the pattern at all. A great MLE knows exactly how to find that sweet spot in the middle.
And then they're going to throw you a real-world fire drill. This isn't about some textbook answer. This is a gut check of your problem-solving skills under pressure. How do you start diagnosing the issue? Do you check if the real-world data is different from your training data? Do you look for something called concept drift, where the underlying patterns in the world have actually changed? This is where a true engineer really shines.
So, let's say you do it. You master the skills, you ace the interview. What does this career actually look like? This is the final part of the blueprint, the impact you can have. One of the most amazing things about this career is just how versatile it is. You are not locked into one little corner of the tech world. Your skills are in crazy high demand absolutely everywhere, from building fraud detection systems in finance, to creating diagnostic tools in healthcare, to powering the recommendation engines we all use in e-commerce. And at the end of the day, this is the crucial point. The reward isn't just the salary. It's about being on the absolute front lines of innovation. It's the chance to work on technology that can make a real, tangible difference in the world, whether that's helping doctors detect diseases earlier or protecting all of us from cyber threats. So there you have it, the complete blueprint for the machine learning engineer. The demand is surging, the work is incredibly impactful, and the path forward is clear. The only question left is, are you ready to build?